So thank you for joining me today. It's a pleasure having both of you on our second chat of this podcast or series. We still haven't come up with a name with it, so we're kind of figuring it out as we're going. But I'm really excited about this, that we've gotten to two now. So why don't you tell me a little bit of brief introduction about yourself? We have Sean and Colin on the talk today. So Sean, why don't you start and give a little introduction about yourself? By the way, thank you for sponsoring the talk today with Neurotex. This is a very good plug. So why don't you give us a little bit of an introduction of yourself?
My pleasure. Well, you guys know me, so thanks for having us, first of all. I think it's a great opportunity to talk about one of the things that is extremely dear to my heart when it comes to the operation and the items that we're all working on. So I am the managing director and founder of Circuit Energy, the sister company to Edgecom Energy that does the engineering, implementation, and operation of some of the assets and some of the projects that Edgecom Energy's customers ask us to do. And in other words, we're the execution arm to Edgecom Energy. We've got 4 divisions over at Circuit Energy. We've got our lighting that is basically divides into 2, one projects and one products. We've got our power conditioning division that deals with the power quality of industrial facilities. And then we also do our distributed energy resources division, which we'll dive into. And finally, our solar division or solar PV division that's mostly focused on net metering and whatnot. I've been in the industry for about 12 years, mostly focused on distributed energy resources. Started off with solar, and prior to that I was in the telecom industry. So it was a switch, but haven't been happier, so that's all that.
Awesome. So what about yourself, Colin? Me and you are colleagues. We've been colleagues for about 2 years now. So why don't we talk about the first time we met, or how you kind of got involved in this company? And
Sure. So my name is Colin Lee. I'm the Vice President of Sales with Edgecom Energy, and my first enrollment here was about 5 years ago. We started with the concept that we're going to help large industrial users in Ontario to simplify their energy management and their spends in terms of electricity. So that's how I got involved. I've been in the industry now for probably decades, so over the different roles I've done in energy and power quality. And so I'm excited to be here today to talk about distributed energy resources and work with Sean and talk about how all these things come together nicely.
Perfect. So we kind of a little bit dove into what we're going to be talking about today, which is distributed energy resources. So
spoiler. Sorry.
No, it's fine. I love when we kind of jump the gun anyways, because that's what we're here for. So why don't we talk about a little bit the kind of customers that get involved in these strategies, and what is distributed energy resources? So you guys want to give a little bit of a background of what this concept is, how it involves with our role in our company, and those kinds of things. So what is distributed energy resources?
Sure. You want me to take this one?
Yeah, totally.
Sure. So in essence, a distributed energy resource is something that can relieve the grid of demand. And so there can be distributed energy resources such as a natural gas generator, battery storage system, maybe even a solar farm, and some kind of wind farm that's combined in a hybrid of all these different opportunities. But that's basically what it does, is it removes demand from the grid. Could also be a business automation system within a facility. And the question was, I guess, how do these come together to help these types of customers that we work with?
Yeah, so why don't we actually, before we even dive in further, why don't we talk about the types of customers and who uses distributed energy resources right now, and why do they have to do them?
Okay. Do you want to try that one?
Yeah, so typically a lot of the customers that we target would be those that have a 500 kilowatt or more in demand, mostly industrial, but we do have some larger facilities like shopping malls or larger condominiums that do have large consumption or large demand. And typically they would qualify as what they would call a Class A customer, meaning that these customers are heavy consumers, meaning that anything that they do to reduce their consumption in a form of a distributed energy resource by reducing their demand would have a much larger impact than, say, a regular homeowner, right? So that's the type of customers that we're after and that we can help out when it comes to the programs that are available in the industry.
Yeah, I would add to that, Ali, if I may, that we're looking at when you ask about the types of customers that we work with, we're looking at customers that are interested in reducing their what's referred to as their global adjustment charges on their bills. And when a larger consumer of electricity receives their bills, there's usually three main components to that bill. There's their KW demand, what they need from the local utility to provide them to operate their operations. And then there's their kilowatt hours, which is how long are they running that demand for. And then there's a global adjustment charge. And that global adjustment charge is basically a pool that's assigned to pay for a myriad of different products and services that the LDCs and the ISO have to cover. And that amount usually runs around $1 billion a month. And so what happens is any individual organization that's participating in what's referred to as the ICI Industrial Conservation Initiative, during those 5 coincident peaks of the ICI program, they create what's referred to as a peak demand factor. And this peak demand factor is basically their percentage of the overall grid during that coincident peak. And so that's where that PDF or peak demand factor is multiplied by the monthly global adjustment pool, which is typically, like I said, about $1 billion. And that's what the GA charge on their electric bill turns out to be. And for most customers that are larger users, that GA component can be anywhere from 60 to 70%. So it's quite significant. And so the types of customers that we are working with, they're looking to reduce that GA component. And so we help them strategize methods to do that.
Just to add, because I think it's a win-win for everybody, right? The operator of the energy grid or the electricity grid would win from a lower demand on the grid by incentivizing these people to bring down their consumption when there is a lot of stress on the grid, right? And that way they can make sure that the grid remains reliable, that their consumers are constantly being fed electricity, and also on the consumer side, they get a good amount of savings on their end. And that's how this whole program was put together, to incentivize, to motivate large and heavy consumers to bring down their consumption and their fair share of that global adjustment charge, so that the grid can operate more reliably.
Yeah, you bring up an interesting point. There's no doubt that the population is growing, and the demand on the grid is growing steadily. And we also know that the ISO and the government intend to shut down, starting in 2024, some of the nuclear power plants. And so as a result of that, the big question becomes, where is this power going to come from in order for the grid to maintain? The government does not want to build a new nuclear station, so they're starting to rely more and more on organizations and distributed energy resources. And these distributed energy resources are going to become a valuable asset, not only for the grid as a whole, but for those who have them and execute them effectively within the programs that the ISO creates.
100%. Yeah.
So I just want to, you guys mentioned global adjustment cost, and you mentioned the grid and how this pool of money helps this out. I just kind of want to get into a little bit of those details of what does this global adjustment cost cover? And then you said that it covers about 60 to 70% of the bill. So kind of get a little bit of a bigger picture here. Let's say, for example, you have $2 million utility bill. 60 to 70% is $1.2 million. $1.2 million of your total utility bill. You said you can reduce this. How much can you reduce this by? And this global adjustment cost, what is this covering right now in Ontario? I'm
gonna use that as a segue into my known example. I give a lot of customers. So you brought up a good point. Global adjustment as a whole, that pool of fund, was created to support a lot of different programs, as Colin mentioned. I don't know if you remember, they used to hand out these coupons for upgrading to LED at Canadian Tire, whatever. There was that money. There was the premium that they were paying on any solar farms or solar installations. They used to pay from what they were charging was about 10 cents cents. They started paying about 80 cents to customers, and they were guaranteeing for 20 years and so on. So all that money, and on top of upgrading parts of the grid and so on, is still coming from that global adjustment fund. Now, going back to your example, let's say that you own a factory and you spend about $2 million a year on electricity, and 60% of it on your electricity bill, you're going to see a global adjustment charge totaling about $1.2 million a year, which is a lot of money, right? And for you to be able to bring down your consumption, we're going to look at it and say, okay, we're going to do a curtailment action plan and tell you to shut down parts of your plant. Then you're going to come back and tell us, hey, you know what? I operate 24/7. My customers are absolutely my absolute priority. I'm not going to be able to do anything with production. I'm not going to be able to, create a lot of discomfort for my employees and whatever. You guys are going to have to come up with a better way of doing this. And that's how the concept of distributed energy resources would be introduced to the whole equation, right? So we look at alternatives, right? So we look at natural gas generators. We look at batteries, battery storage units, so that we can displace your load at times that there's a lot of stress on the grid, so that in the eyes of the operator of the grid, you are off the grid. You could potentially and virtually bring down your global adjustment to zero for that period if you're able to, in the eyes of the grid, shut down your facility. We're not shutting you down. We're just basically giving you power from a different source, and that's owned and operated by you, and you become a very important player in shaping how the grid sees your consumption throughout the year.
So it's very interesting you mentioned that. So you can actually bring that load down to zero. So if you have
100%.
$2 million utility bill, now your $2 million utility bill is only $800,000. So that kind of gets us into a very interesting topic of now the customer side. So Colin, you really deal with the customer. Why is we see why it's important for the customer, because they have such large savings, but these are just strategies. So why is this both important for the customer and important for the IESO?
Well, going back to the comment earlier that the IESO and the Ontario government will be starting to turn down the Pickering nuclear station. The question becomes, where's that going to come from? So that's where we mentioned earlier, it's important for those who are sort of progressive to get these kinds of assets, these distributed energy resources in place. And right now, the way the programs are structured for the IESO, the ICI program in particular, these assets can be basically justified based on the reduction in their peak demand factor. So helping customers strategize a way to, with no capital, acquire these assets, take advantage of the savings that they generate to cover that. It helps them accomplish their goal, and then hopefully in the future, as time passes on, we can find other ways to stack further benefits for these customers from these distributed energy resources. Might even be something like the operating reserves, helping them participate more in the buying and selling of electricity on an ongoing basis every day. So there's lots of opportunity for them to build a business case that makes sense for them. And so our role is to help them identify what path is best forward for them from here.
Perfect. And so now, why is this important for the IESO? So we talked about the customer. Why is this important for the IESO?
So I'll give my take, and I think Colin will have something to say about that as well. But I think part of it comes back to the fact that the grid, the electricity grid, is aging, and it's been, parts of it has been, been obsolete for years, and they're having a hard time keep up with all the demand that's happening, and all the growth and the population increase and all the factories coming to Ontario, and all of that is creating a demand that they're having a hard time keeping up with. And it's also worth mentioning that any electricity that's generated by the Ontario Power Generation it has to be consumed. There's no way of storing it anywhere, right? So for you to keep up and come up with models that are constantly and vastly changing with the introduction of electric cars, with the introduction of all these new facilities that have complex infrastructures and so on, they're using and demanding a lot of electricity, it's becoming more and more difficult to predict how much consumers are going to be needing in the electricity that's generated. So ultimately, how this affects IESO is that, okay, they're going to wipe their hands clean of any kind of prediction. They're going to eventually in the future come up with plans that there's not going to be a massive power plant anymore. There's going to be multiple distributed energy resources, and they are on demand. As they need it, they will demand for it, and they will start introducing it, right? And that's how I see is a win for the IESO, and that's how they're going to be able to maintain the reliability of the grid.
Right, and to add to that, I mean, the why does the IESO or the government want these DERs in place is that we're all moving towards a reduction in greenhouse gases.
Yes.
And so right now, currently, the nuclear stations that are online are running full out. And then when there's demand gets beyond what that's able to be serviced, comes the hydro. They're running pretty much full out all the time too. And then finally, when the demand gets so high, we have to start bringing on these tweaker plants.
Yeah.
And it's these tweaker plants that are usually natural gas generators, and this is the greenhouse gas emissions that we're aiming to reduce. So when you take away a portion of the nuclear component, where's it going to come from? Well, this is where the battery storage in particular, as one of the types of distributed energy resources, can come into play. And when you have a bunch of these distributed energy resources throughout the province, all of a sudden they're supporting that demand in an on-off capacity when there is demand. And that's where the DER benefits the grid as a whole.
So I'm just going to throw a little buzzword out here, what you guys mentioned. This is what, when you hear on like the news and stuff, this is virtual power plant. This is what you're talking about, because what you're doing is you're lowering the demand and you're lowering the amount that needs to be generated. But at the same time, because you're lowering demand generation, you're reducing the amount of traffic that's on the infrastructure. And then this way you have to do less renovation on the infrastructure,
Yes.
and that also lowers down the global adjustment cost. So it all comes
100%.
back, couples all around together.
100%.
So you guys talked far into the future. Where do you see DER going into the future? Where do you see the change of the progress of DER going towards in the future? Or the evolution of it all?
Well, I think as long as the end user who's going to have a DER on their premise can benefit from it from an organization, like their core competency is to do whatever they do. And if we allow them with a DER to do that even better, and then even provide some backup power in case of emergencies while participating in these programs, while reducing greenhouse gases, while improving the grid reliability, then it seems to be the direction that we ought to move. And this is where the government and the ISO are painstakingly working together with larger stakeholders to try to streamline this process, because we need more of it, we need it faster.
And I think to add to that, I think the vision that I have in mind, and I think a lot of the input that we're getting from the industry and from all the players in the market, is that we're moving into a blockchain managed micro distributed energy resource future for the grid. What I mean by that is every little source of power is going to be a contributor to the grid in the future, and that's going to be managed by a blockchain that's completely secure and fully automated depending on what demand. We're seeing a lot of electric cars driving around in the city. Imagine every single one of those cars are going to become a mobile battery storage unit. So when the time that they're parked, when you're at your office, when you don't need your car, the utility could demand the power that you currently have, a portion of it, on your vehicle based on an agreement of some sort, to inject into the grid, and you multiply it by thousands, millions, and you all of a sudden have access to a substantial amount of power at any given time without demanding power from natural gas generation that is affecting our environment. So that's the idea.
I actually have an interesting question to ask you. If you have these battery energy storage on site and you have enough charge and the grid needs it, are you able to sell it? Like, can you sell your load to the grid, or create revenue for yourself, for your own company, and throughout this way, not only curtail and bring down your utility bill down, but can you also use it as an asset to create revenue for your company?
Absolutely.
Yeah, these distributed energy resources, such as the battery storage in particular, they, once they're installed and they're operating, we have to pass the connection impact assessments with the local utilities, and then we need to get the buy-in of the ISO. And once that asset is registered, and there are different levels of registration. Once it's registered, certainly you can sell it back, and that's just another revenue stream that can be generated from that asset for the organization who owns it.
Interesting. Yeah. So now that, let's say I'm a company right now, I want to do battery energy storage. I need to reach out, I got to do a lot of research. I can do this in-house, or I could go for an energy management company like ourselves. What brings these two companies together? Why would I need an energy management company, or why won't I do it in-house? Because we've come in contact with a lot of customers who've actually tried to do it in-house, and they've reached roadblocks, they've reached places where they don't feel like they can get to that point. So why do they reach out to energy management companies, and why is it so important for that to be part of the process as well?
Okay, so
we're awesome.
No, I'm not to say that. To say that we're awesome, but I know that there's a lot of energy management companies. What's the use of them?
So basically,
Good point. Good question.
Normally these types of projects, manufacturing and other people that are interested in participating with these kinds of DER projects, they do not want to capitalize them. They've got they've got a core competency, which is their business, and they want to remain in that core competency. And so they want to work with organizations like ourselves who are able to help them not only strategize how these DERs can benefit them, but basically hold their hand all the way through every step, and even manage the operation blind eye to them, but release the benefit to them, so that basically, as a third party, you're doing everything for them, they get the benefit.
Yeah, that covers it all in a nutshell. I mean, it all brings it together in a way that you remain focused on what you do best, which is your core business, your core competency, and let somebody else take care of it as an operating expense, not a capital expenditure that you'll have to spend money on something that you don't even know how to operate.
Exactly.
Right? And you take advantage of all the benefits without risking much.
So, in the sense that I'm understanding is that you want, for example, for your company to continue that revenue or that business that they're going on, engage in an energy management team, because not only will they buy the asset, but they can implement it well, do the operations for you, and then you have the savings, you can create the revenue.
That's right.
And as that kind of holistic approach or kind of sort of things. Now, what are some of the roadblocks, or what are some of the problems that customers come into when they try to implement these projects, when they reach out to energy management companies? What are some of the things that you've seen yourself, Colin, because you've talked to so many different customers and companies right now?
Yeah, this is a little bit of a long one, so I hope I don't go too much detail.
No, don't worry, take your time.
But my experience is there's three major stakeholder groups involved in these types of DER projects. One is the operations side, so you've got your engineering components from the customer side, the physical connection to their distribution network and their transformers and so on. So that is all engineering, and Sean's team from our side manages that communications with the customer's communications. So traditionally that's not too complicated. That also involves the connection impact assessments with the local LDCs. Again, not too complicated from our perspective. The second group that we find as stakeholders within this is the legal department. So anytime there's an agreement, the legal department wants to get involved, and so they should. And I think the biggest problem we've seen in the past is the term of the agreements. Customers were presented distributed energy projects that were 10, 11, 12-year long terms, and the legal department had a real challenge with that. They had challenges with all the cancellation clauses and so on. So we've worked hard on our side to simplify that process for our customers, and I believe confidently that there's not any real legal hurdles that we can't overcome. Everybody has a slightly different perspective on things, but we work with them. I think where we saw the biggest problem in the past was related to the purchasing department. These projects, as was related to earlier, are typically, or have been typically, a capital purchase, and so organizations just don't seem to want to make those capital purchases any longer. And so we're trying to position it so that it's a no cost upfront, no cost to operate, you just receive the benefits, but then we have to make some sort of financial agreement. And so there's been different models presented in the process, and we think we found a way to help customers. The first model was traditionally a fixed monthly payment. Customers often thought, or the buyers often thought, that was basically another form of a lease or a capital expenditure, and so we moved into the next phase, which was a split shared savings. Again, that was considered perhaps as just a different version of a fixed monthly payment. And then the next model that's being presented today in the marketplace is these basically an effective reduced kWh rate. So if a customer is paying for conversation 10 cents a kilowatt hour effectively over the year, if we can enter into an agreement and say, look, we guarantee your effective kWh rate is going to be 7 cents, now the buyers can buy into that because they got a guarantee over that term of the agreement. So these are the three categories and some of the hurdles that we've addressed and overcome.
And it eliminates a lot of these hurdles by, I guess...
Sorry about my little computer. I just got an email, but you're after yourself.
And it eliminates a lot of these hurdles by kind of removing the complexity of dealing with the financial model that is required to justify on their books how this asset is going to operate. And the setup that we have resonates well with a lot of our customers based on the conversations that we've had in the past, because the term is limited, it's short, it's and they have no upfront money that they have to pay, and it's strictly an operational expense. That's the beauty of it.
So just to sum up a couple of things that we've talked about today, we've seen why DERs are important. We've seen how it's important for the ISO. We've seen how it's important for the customer and cost savings and all those things. So moving on in the forward, do you see more and more companies getting involved in these strategies? More and more companies becoming educated in these strategies? And do you see it becoming a very common practice towards large manufacturers?
If I may, I don't think they have any choice. It's inevitable. It's the way the industry is going. It's as if you asked, 50 years ago, do you see computers being deployed all across the industry? And some said yes, some said no. But now we see that the reality is that everybody has got a personal computer. And I see that the way the industry and the energy industry specifically is shaping up is going to really force everybody to line up towards that ultimate way of consuming electricity and being part of that smart grid that we all talk about.
Yeah.
So before we drag this on a little bit too long for our production team's kind of getting a little upset at us in the background, I'm just going to quickly wrap it up. Do you want to say any closing statements or any closing words about DERs that you still feel like is the last points you want to hit before we end this chat?
Colin?
I think it's the one thing I would say to people that are considering DER projects is keep in mind the duration of the projects. These are not done in a week and a month. These are typically a year-long process, and they are tied typically to the programs the ISO has, particularly the ICI for the GA savings. So there is somewhat of a cyclical timing on it. So if you're interested in talking about a DER, you want to give yourself minimum 12 to 18 months in preparation, and then you want to link it to that May 1 beginning of the ICI program. So that's the piece I would advise on people.
All right, and to add to that, I think we've heard this in the past, and I think it's one of the key concerns that a lot of customers have. What happens if ICI goes away? And I think based on the experience that we've had in the industry, and based on what we're seeing, and based on what's at stake here for the economy of the province and the country itself, they may evolve the program into something else. But ultimately, what's important and what we have to remember is that a distributed energy resource is here to stay. Period. There's no way around it. All the strategies that all the government level entities have done, and the roadmap that we're seeing is pointing in that direction.
Well, thank you for both being on the chat today. We dove into a very complex problem, try to do it as short amount of time as possible, but I want to thank you both for coming in and joining us in this chat.
Thank you very much.
Thank you.